So we have another question from the heat transfer section of thermal properties of matter. It says 3 rods of material X and 3 of material Y are connected as shown in figure. This is the figure. All the rods are identical in length and cross-sectional area. If the end A is maintained at 60 degree, we can see 60 degree, and the junction E at 10 degrees Celsius. Calculate the temperature of the junction B. The thermal conductivity of X is given and that of Y is given. Now let us see how we'll proceed with this question. So first we can see that this is analogous with Wheatstone bridge. Wheatstone bridge is a concept that we use in electricity chapter, electric currents and its effects. But since the thermal properties of matter part, the thermal resistance part is analogous with the electrical resistance part, we can apply that concept over here as well, since the difference between C and D remains 0, hence no heat passes through this length. Now let us convert it to the resistance form, say 60. Now since we know that L and A is same for both X and Y, so let L by KXA equal to R. So now either we can assume another R with L by KYA taking thermal conductivity of Y. But since, as you can see in the question, that X conductivity of X is 800 and Y has half the conductivity of X, so since L by KYA equals L by KX by 2A, since it is the half of 800, equals 2L by KXA equals 2R. Therefore you can see this is X, X and X, therefore we'll write R, R and R. This one will ignore as per Wheatstone bridge, since this is a balanced, again this is a balanced Wheatstone bridge, since 2R by R equals 2R by R, since it's symmetric on opposite sides of the junction, it's a Wheatstone bridge formation, therefore no heat will pass through this one. Okay, so this circuit is equivalent to, so you can add this now, since there is no junction here, these are in series, 3R, 3R. Now we can add this as well, since these are in parallel, so this becomes this, this becomes this, and this becomes this, which will be equivalent to 3R by 2, which is equivalent to 3R by 2 plus R is equal to 5R by 2. Okay, so now as we can see, we've come till here. Now the next part of the question asks us the voltage of this junction. So what we can do is, now the equivalent resistance of the whole circuit is 5R, as you can see 5r by 2. Now this is 5r by 2, this is 60 and this is 10. Now as we know, the Ohm's law analogy for thermal heat transfer is IH equals delta T VH by RH, which is dq by dt equals delta T by R equivalent thermal. So we'll let this just be IH net. Since the R equivalent is for the whole circuit, the I will be for whole circuit. Since current here and here is same, but then it divides into two parts, equal parts, since both branches are the same. So if we had to find out, we'll just divide this I net by 2. Now delta T is 60 minus 10 upon R equivalent, which is 5R by 2, which is equal to 2 times 50 by 5R. Now 50 and 5 will cut off and this will be 20 by R. Now we have the I net. Also, the second last step before we found out R equivalent. So this was point A, this is point B. We need the voltage for point B. As you can observe that the voltage for point B will be the same as the voltage received by this 3R by 4 resistance, thermal resistance. This was R, 3R by 2. So the thermal current received by this 3R by 2 resistance will be the same as the one received by point B. Okay, so for this we have the simple formula that V1 equals I net into R1. See, it's quite simple. So what we simply have to do is, we know that the V1 is equal to, since it's between point B and point E, so the V1 for this will be B minus 10. Since B will be greater than 10, we'll write down TB. Now mind you, TB is the temperature we have to find. TB minus 10 equals I net. We've just found I net, which has come out to be 20 by R. 20 by R into R1. Now R1 is R itself. So we'll go that way, which is come out to be 20. Right. Therefore R1 is 3R by 2. So this is equal to 2 by 20 cuts off and we get 30. We get the minus 10 here, which is plus 10, and we find out that TB has the value of 40 degrees Celsius, and this is the required temperature as per question.